With Sunil Parekh. I work for Cisco Systems, and as a part of this emerging tech bite, we are introducing a basic series on 5G. So the purpose of this overall series of sessions that you will see in this is to learn 5G from the scratch. This is our first session. I welcome you all. And as you must have been aware that the spectrum allocation for 5G is happening all over the world. And of course, in India as well, it happened very recently, where the telcos took part in the auctions and they got their shares of the spectrum. And from the government side also, there is something called letter of authorization that has been issued so that the telcos can go ahead and deploy 5G network in India. What does this letter of authorization means is that now telcos are ready to deploy their 5G infrastructure. And 5G, you must have all heard this term in one way or other. It is basically taking our communication to the next level. Why I'm saying so? Because these days in 2022, the connectivity has become so important that people have come to think about this like electricity. So it should be always on and available everywhere. So regarding this series, this is for the absolute beginners or the network engineers who have somewhere around 3 to 4 years of experience and want to learn 5G from the scratch. If you are someone who is good in some very basic concepts of networking like bandwidth, latency, and then some of the concepts around frequency division multiplexing, time division multiplexing, now I will be explaining these concepts in bit in a very high level, then you are good to walk in into this series. So with that, let's just get into our very first session of this series. First, we will be talking about some of the numbers around 5G, what 5G is actually promising us. This is just to create some interest in this technology and why you have or you are seeing so much of hype around India as well as the globe. Then we will dig deeper into, well, not deeper, but again at a high level, what 5G is all about. We will be looking at some of the capabilities or the use cases of 5G. And towards the end of this session, so this session is at a very high level, focusing only on the use cases or what 5G is. We will shift our gear towards a bit technical side on what makes a 5G network. And then in the subsequent series, we will slowly open this bullet number 4, what actually makes up a 5G network. So with that, let's just start. And it's a time for a tip. So the first operational 5G network that was demonstrated was in 2018 Winter Olympics that had happened in South Korea. So there are already some operational 5G network, be it in standalone or not non-standalone mode. Don't worry if you don't understand these terms as of now. By the end of this series, you will understand what is mean by standalone, what is mean by non-standalone. But what the point that I'm trying to make with this tip is that already there are some operational 5G networks that are there, and more you will see in the near future. So with that, I welcome you all. Come and learn 5G with me in this series, as this revolution has just begun in countries like India. And One more thing before I get into some of the hype around 5G is that the technology revolutions are happening at a much faster rate than it was like previously. So you must have seen like from 3G to 4G transitions that were happened. So the time it took from 3G to 4G, it will be much lesser when it comes from 4G to 5G. So the pace of the deployment will be much faster. So yeah, it's the right time to learn this technology. With that, let's just look at some of the hype around 5G, what 5G is all about. So the first number that we all get excited about is that it supports much more bandwidth. So the uplink and the downlink bandwidth that 5G promise is 10 gigabit per second. That's a huge bandwidth. And in some papers, you can see that it's actually around 20 Gbps. That is considering up and down both. If you add up, that number comes to this. That is the enhanced bandwidth that it provides. Then it provides us the latency somewhere around 1 millisecond to 5 millisecond is what a 5G network promise. And for those of you who are absolute beginners, network latency is something that is the time that is required for a packet of data. Let's say you have two hosts from here to here. So when the packet move from this point number one in this direction to two, and it comes back, is called latency. So basically the round trip time. And 5G offers somewhere around 1 to 5 milliseconds. Download speed, it offer 100 times faster download speed. So this will be much faster. If you are downloading a movie, let's say on a 5G network, it will be downloaded in uh, somewhere around in some seconds or minutes. And moving on, there 5G will support more and more denser deployment. So what it claims is that there will be like 1 million or 10 lakh devices that will be connected per square kilometer. Don't just think in terms of mobile phones when you are looking at this use case. There will be many more sensors that comes into the picture when with which need connectivity going forward. So we will be looking at these use cases. These are just for now. Just look at these numbers. These are some of the numbers that you see around, and we will drill down like where these numbers are applicable. And finally, it support five nines of availability. That means it's a very highly available and a reliable network. So you see, these are the numbers which 5G is trying to achieve. And standards have defined these numbers in the 5G specifications. How can 5G achieve these numbers? But the key thing, and please pay very close attention to this, we will uh, open this point in our subsequent series of sessions as well. For the most of the 5G cases, it will not support all of these at the same time. So you deploy the 5G and then tailor it to your specific needs. And we will find this in our subsequent sessions where we will be talking about the spectrum allocations, uh, where we can get the high bandwidth, where we can get the higher coverage, and all that aspect. So currently, just know that, okay, these are the numbers that 5G support. But by looking at these numbers, currently it sounds like too much. And in one of the 5G class, one of the user asked me, like, don't you think that these are like a too much number for an individual? The answer is maybe yes or maybe not. But it is not only the individual users who will be the consumer of 5G. It will be the enterprises as well. Different enterprise will consume 5G. These enterprises can be your industrial uh, companies or like manufacturing, automobile, or mining companies. All these are the bigger enterprises. They will also be the consumer of 5G. So when you look at these numbers from an individual user perspective, these may not make sense. For example, 1 millisecond of latency. Like if you are not a avid game user, 1 millisecond of latency may not mean much to you. But think about an enterprise who is having some mission critical, time sensitive application. So overall, before we move on from this slide, just think that these numbers, these standards have defined keeping the consumers in mind. And consumers are not only the individual users like you and me, it is the enterprise as well. Okay. So now let's just look at what 5G is. And we have seen like it sounds like an obvious generations of 4G, the successor of 4G. And this had started from 1G. And with every generation, there was very specific use cases that it was addressing. And that's how this generations had evolved, and now we are seeing 5G. So if we look at the history from the 1980s, it was mainly designed for the voice, and the medium was analog for this. Then in the 90s, we have shifted towards 2G, and where the era of SMS was started. Along with the voice calling, we have also started sending some text SMS. Around 3G, there was this video, which was the main focus. Believe it or not, that was the intent of 3G, but that didn't happen with 3G, of course. And then we saw this 4G that had come, and that had taken the internet to the next level. And this was the time where a lot of apps or lots of users who have gone online, especially if we look at the India, the Geo Wave that came in 2016 had completely transformed this. We all went online, browsing something on YouTube, or heavily dependent on the apps like Ola, Uber, Zomato, or any other uh, such apps. And everything was happening online. The e-commerce boom that had happened on the Flipkart or Amazon. So this had taken the internet to the next level. Now with 5G, what exactly is the focus? So 5G is for the connect experience, basically. It will take our internet experience to the next level. And I'm just having a question mark here. This is what we will open up in the next slide. But before I go into this 5G use cases, let me just give you a glimpse of who defines 5G. I think that is the next slide. So we will come back to this slide earlier. So who basically defines the 5G? So the 5G is defined by an ITU. ITU-T, this is a organization which defines 5G. So 5G was the result of IMG 2020 specifications. Uh, so IMT 2020 has defined the objectives of 5G, and then it was picked up by 3GPP, which is actually another standard bodies of uh, telcos and vendors who actually work on uh, the implementation parts or define the standards like how 5G will be implemented. So these are the two bodies, 3GPP and ITU-T, are responsible for defining 5G. Now let's go back to our previous slide. I'm sorry, there was a goof up in the slide, I think. So now let's go back to our previous slide where we are defining the use cases. So whenever you see about any of the 5G use cases, those are actually defined in these three categories. And there are these different release documents that come out with some specific use cases. So as a part of release 15, enhanced mobile broadband use case came into picture, which support higher data rates and higher traffic volumes. This is where we saw that 10 Gbps number, right? So EMBB is the first use case which many telcos are in fact trying to address. And with the rollouts that we are seeing around us, this will be the first use case. Now you may not see a speed of 10 Gbps because that's the ideal, that's the standards that define, but it will be much faster than what you have currently on your 4G phones. Then we talk about ultra reliable low latency. This use case was defined in release 16 and 17. This was the use case where we saw like that 1 millisecond to 5 millisecond of latency, and it is actually a very reliable number. So if you recall my previous slide, I showed 5 nines of availability as well. So this is where those numbers get tied to this use case. So it will be very low latency and then highly reliable as well. And then as a part of release 17, there was another use case which was massive machine type communication, where you will see a massive number of small devices. Remember, I was showing you like 1 million or 10 lakh devices per square kilometer, right? So that's what we will see in this. And again, I'm reiterating, whenever you are looking at these 5G capabilities, don't just think about individual consumers, think about the enterprise segment as well. And we will cover some of the use cases as well. So this we have already covered. So now let's just take a bit of technical terms. So far, we have kept the session at a very high level. Even in this technical discussion also, we will be keeping our focus at a high level. But what makes up the 5G network? From a 30,000 feet overview, what you will see is there are like three major parts. One is this UE, then we have the radio access network, and the third one is the mobile core network. These are the three individual pieces which makes up the 5G network. And then you see these individual plus signs in between, which are actually connecting these domains. So what comes under UE? So UE is your user equipments, basically your endpoints. So far, what you have seen in case of 4G is the cell phone. In 5G also, cell phones will be there. But again, there will be lot many enterprises that will be the contributors. So you can see some machines are also using this network where you will see a lots and lots of sensors. These sensors are like very small, low power devices which need very reliable and consistent connectivity. They are not sending that much of data. They are just sending or answering to some probes which are very light in nature, but it is it require a consistent coverage. And we will open up by the way this in and I will cover some use cases dedicated to this machine to machine communication in the next session. Then comes the radio part, where you see all these cell towers. So that makes your radio access network. And how does this RAN talk to the UEs is via the spectrum. This is actually a very important piece in 5G or any other mobile communication. Spectrum plays a key role, and this is what I was talking. The allocation of the spectrum has happened very recently in country like India and across the globe also. There is a 5G spectrum allocation had already happened or are happening as we are delivering these sessions. Right. So this is a key requirement for a 5G. And what this spectrum is all about, what is low band, what is mid band, right? What are I'm running out of space here. So what are like waves? Hold these thought for the next session. We will cover this, and we will also cover the use cases like spectrum. What uh, range of spectrum serve what purpose? Then we come to the core part. So RAN we have already covered all those cell towers that you see, and we will be covering some of these components like the G Node B and other mobility components in subsequent session. The mobile core network is the key piece again for a 5G network where your IP packets are generated. So it is responsible to generate the IP packets and send it further towards the internet, or when it gets a response, it sends it towards back to the UEs. So this is how the communication happens. Of course, this RAN comes into the picture because that is the medium for a core network to connect to the UEs. But apart from IP packets, it also helps to authenticate the UE. Core network is responsible when you are moving from one cell tower to another cell tower. So it keeps your session intact. And there are so many other functions, control plane functions, data plane functions that come into core. It's very difficult to cover core in this introductory lecture. We will be having a dedicated sessions for mobile core. And to connect the radio with the core network or to connect all these pieces, we have something called a transport network. So this transport network is the connecting piece which connects the RAN to the mobile core, or you must have seen that SP transport network. If not, don't worry about it. We will cover this piece as well. So these are the individual pieces. Again, three domains: UE, radio access network, and the core. And to connect this, we have spectrum, which is like your air interface towards the UE. And if you come towards the core side, there is this transport network. And there are different deployment methods that are available. You must have heard about SA. I was talking about it initially, and then NSA, standalone, non-standalone. Uh, Request you to wait for what exactly this is. I will explain this in our subsequent session. We are already like 30 minutes into our session, so would like to wrap this very first session. I hope this was informative for you, and thanks a lot for listening to this. Happy learning.